Okay, so I want to do a demo of this thing I've been working on. I've been calling it the Good Game Engine or the Good Game Library. It's a STL3 wrapper for the Janet programming language. But I've sort of, as I've been working on it, I've become more and more opinionated. I'm trying to make it a productive prototyping engine for small games. I think JLib is a good option for Janet if you want to make games and you want to already have a lot of things built out. The goal for this is that instead we provide a wraparound STL3 instead of Raylib, and the APIs are very close to STL3, but we've got some sort of productivity features and some Love 2D inspired design that you could use instead. So I was thinking we could make a little juggling example, and I could show you some of the productivity things that I built into it, and maybe some of the other features. And we'll start really simple with a hello world, and we'll go through and try and build the whole thing together. So we could draw just like SDL. If you want to draw, first you have to set that color, and then we'll put some debug text right at the edge. We'll do our hello world will be hi instead. Build hello, and then I put this in examples juggle.janet. Great, we've got text real tiny in the corner up there, so it's a start, but we could do better. Let's first thing I like to do on these example ones, because the font is like a default size that you cannot change, the debug font is from STL3, is for little examples like this. We could just set the scale to be twice as big. That way when we open it, it's at least legible. It's still not big, but it's legible. But as you've seen, I've been restarting the application every time I make a change. I personally don't like that much. So I want to get as close to sort of the REPL-based development as we can. Though it's not exactly REPL-based, but I want to be able to see changes as soon as I make them. So I added this config option that auto reload true, and then we just have to restart one more time, and now the engine will watch this file for you, and when it sees changes, it'll update the application pretty much immediately. I added this debug logging where it says reload in the logs when it gets reloaded. Hopefully that's helpful as you're watching, because it's kind of unclear when I'm saving. You could also look down at these little asterisks here. When they go away, that means that I've saved the file. So like when it's, if I want to change this to hello world, you could see the file's unchanged and now it's been saved and it updates. But hopefully that makes it easier to follow along. So yeah, this is sort of what the hello world example looks like. Draw is called on every frame. Setup is called once at the beginning of your application. And config is called once before your application has a window. So this is pre-SDL setting up. This is after SDL setting up. And we have a few more callbacks we'll go through. One of them is on event, and we're going to use that next. Well, I guess it's worth pausing actually to explain the state thing that I've been passing through everywhere that doesn't get used at all yet. So I, in the engine, maintain a state variable for you. The idea being is that this is a state that does not get reset on reload. It only gets reset on reset, which we'll call setup again. The idea being reloads are lightweight and resets are heavy. They reset everything. So let's actually sort of, we could do an example of that. We'll add in our state some things. So maybe we'll do X and a Y. And maybe we'll use this as our X and Y position in here for our ball that we're going to juggle. So we're going to draw a circle at X and Y, and we'll give it a radius of 10. We could use Janet's destructuring to easily get X and Y from the state. I really like this API. It makes it feel super handy. So now when I save this, we get an error because we don't have X and Y. Because like I said, setup does not get rerun automatically when you reload. However, if I press 1, I can reset and get X and Y set for us. Though, did not work. Oh, I see. It's because I have a typo here. I did Y and Y. Now if I reset, I'll get it. Great. So our circle's at 10 and 10. Our text is over it. That's kind of not great. We could move our circle to the middle of the screen instead. So if we set our window width, the default width is 800, but we're going to do 400 because we're at 2x scale. Default height is 600, so we'll do 300. And then I'm going to go ahead and do our half widths and half heights to 200 and 150. That way we could use that here to put the ball in the middle. Half width, half height. And then, like you can see, our application is reloaded, which means setup did not run. So the ball didn't move. The ball wants to stay where the state says it should be, which is really nice. Later, you'll see it means you can make changes to your application and the gameplay keeps going, which is really, really handy, I think. However, in this case, we want a way to see the change that we made to setup. So the easy way I've found to do that is use our onEvent hook. So this gets called when events happen in SDL, like mouse movements, key presses, all those things. So I have been favoring using the one key to reload. The true here is that the key is down. False is that it's not repeat. And then instead of reload, which you could also add to your code, we do reset. So this will take that key event, 1, and then when that happens, when I press it, so I focused our window and I'm pressing 1, it'll run our setup block again and give us a brand new state as if we just started the application for the first time. So kind of handy, easy to make it so you could go back and forth between things without too much issue. So yeah, we got our ball on screen now, and we're able to reset quickly to our standard state. Let's go ahead and add some physics for our ball. So we're going to try and juggle it, so we need it to drop. So just like other game engines, we have a separate callback from our draw callback that you want to use for things like physics and game state updating. So in here, we're going to have some idea of gravity being applied to the ball, and we'll apply it here. So just for keeping it simple, we'll just say, we'll destructure like we did here to get X and Y. And then I think what we'll do is we'll put in the state the new X value, which I think we could just add X plus delta time should make, X will go to the side. Probably want to do Y for gravity. There we go. I'm pressing 1 here to reset, and you can see it's quickly dropping off the screen. We could give it a speed to make it fall slower. One more paren. This is one thing that I have in this that I haven't seen in other hot reloading systems, is that it's very easy to go from a error state back to a working state. So like if I introduce a mistake, I get rid of my parentheses here at the end. I have the error screen here. I think even when I've done hot reloading in Love 2D, the error screen often means that you need to restart the app. But in this case, as soon as you fix your errors, you'll resume right where you left off. And then I think that's partly because I've built in this state concept, so I know what to reset and what not to reset when you make changes to your application. And the other part being it's how I want it to be. So one thing that might not be clear from this right now is that things in setup are not rerun. Everything else gets rerun, including things in the global scope. So if I want to set my circle radius to 30 instead, I could set my circle radius up here. And then as soon as I set that, it'll change. And if I change this, to 20, it happens right away. It's just the things in setup not getting reset. Your state stays the same so that your game keeps playing even as you're making changes. So we've got a ball that's falling very slowly. Let's go ahead and also extract out this gravity speed. We'll just call it gravity. Yep, got to close that. And then reset. And yeah, it's pretty good. I think next thing we're going to want is to put a paddle so we could catch that ball before it leaves the screen. And we'll probably end up speeding up gravity a little bit. So let's start our paddle at the bottom center. Maybe it doesn't matter. So I think what we're going to do is have our paddle follow your mouse as it moves. So we could start it at the edge of the screen and it'll just zip to your mouse when you step over the window. We want to set our Y to be like almost the bottom of the screen. So we're going to do window height minus 20 maybe. And then let's draw it and see how it looks. So for this, we're going to draw a rectangle. Our X and Y will be our paddle X and Y. So let's break out this destructuring a little. And then put that in here. And then we can't use the radius. What do you say we do 60 by 10? See how that looks. Where did we go wrong? Line 37, bad slot, 0 expected number got nil. All right, so this is our thing. Because state has not rerun, these keys are not here at all. So if I focus the window and I press 1, it'll fix it. Great, so now we have a paddle. I think that looks okay for now, but we want to make it follow our mouse. So let's add a new event here on mouse move. We get our X and Y of our mouse, and then we're going to put in state the paddle X is going to be just to get it working. Let's set it to your mouse's X position. Let's see if that worked. Okay, it's working, but it's exaggerated, and that's because the Windows X is not scaled. So I think I need to do this divided by 2. Let's see. Now, yeah. So it stays on my mouse. I would expect this to not stay on my mouse, though. I'd expect the middle to be on my mouse. So I need to scoot it over by half the paddle width. So I believe I set my paddle width to be 60. Let's extract that out, put it in a variable at the top. 60, and then paddle half width will be 30. And then now I could take my paddle X, and I think I need to add paddle half width to it. So let's see. Okay, other way. Subtract, I guess. Let's try that. Oh, not good. Not good. I think this is the sides being wrong. Here, let's break this onto a new line. Subtract the width from the mouse position instead. There we go. That looks about how I'd expect, but obviously our big problem is that we don't have any collision yet. So I'll just leave this here and go back to this window, and I think, yeah, it'll just go right through. So let's go ahead and make it bounce now. So if we want to make it bounce, we want to add in our tick here something that, I'll take our destructuring from here, get our paddle X and Y too. We want to check if the bottom of our ball has touched the paddle, and then when that happens, we'll add to the ball's speed. You know, this one thing I'm realizing is that we don't actually have a real ball direction yet. We'd probably need like a delta X and a delta Y. That's the direction and speed that the ball is going in X and Y. So we could add those. Just to test them, we'll set them to 1 and 1, and it should head off down at an angle. So instead of applying the gravity directly to the Y, we're going to multiply delta time by delta Y. And then when we reload, oh, we're still going straight down. Oh, because we don't do X. Great. Now we head off at a weird angle. I think we want our, let's start with it not moving so that we could see gravity get applied. So now what we want to do is, like, slowly over time, we want to add gravity to our downward momentum. So we'll add to our dy. It'll be dy plus gravity times delta time. Great, that's working, but accelerating very, very quickly. That's a little better. I do think we probably want to put a cap so we can't get going too fast. Maybe here, just to make it more fun. So for that, I think we want to do we only want to set the dy to this if we're under the gravity max. I think the easy way to do that is just say the minimum of this and gravity max. Let's see if that worked. So if I move this up, the max speed goes up. I think 0.1 is better. Let's make this lower so I can see it accelerating a little bit. See if it's, yeah, it does get going faster. Okay. So now I am wanting my paddle to be in the middle of the screen now because I'd like it to be underneath the ball automatically without having to move it to the side. So I think I'm gonna go ahead and change that. So we'll put it at window half width minus paddle half width. Unknown symbol. Oh, yep. I do need an E. Great. So now it's underneath it automatically when I reset. I don't need to go over there and move my mouse to be under it, which is handy. So now that we have a gravity, we should be able to apply this gravity all the time. But then if we've collided with the paddle, we could change our delta y to be a negative number, which will make our ball go up again. Seems like it's a okay way to do it. There may be a better way to do it, but this is the way that makes sense to me. So we want to check if we hit. I think we're going to need a few conditions for that. So we're going to say if the, let's say x is greater than paddle x and it's less than paddle x plus paddle width. So we're x and y within it. And then we want to check that we are our y is greater than our paddle y, which means we've hit. We need a condition just to test. Let's do hit. And then we'll reset here. Let's see if we're saying hit all the time. So that's not right. So paddle x, y is greater than paddle y. How about this? Nope. Oh, wait, did we stop printing? Oh, we stopped printing. Okay. We print until we get past it. So I think I am backwards on my y now. Now we're saying hit because we're under it. No, we're saying hit all the time still anyways. I do know we need this to say when the edge hit. Maybe I could add some debugging here. X, Y, and paddle X, paddle Y. Oh, maybe it's working. I think I'm not printing hits when it's above it. Let's move our ball up a little or make the gravity weaker so that I can check the logs a little quicker. So I think right now we're not hitting. Okay, yeah. It is working. And then we start hitting. So that's good. We should add one more, I guess, that it's also the Y hasn't passed the middle. So when it goes off screen, it's no longer hitting. So we just want to be hitting while it's inside of the paddle. And we go a little further than we need to, but yeah, that seems good because we should bounce off. Okay, great. So instead of this, let's bounce our ball up. So let's give it -3 push upwards. See how this looks. Whoa, way too high. Try -1. And reset. Oh, it's still huge. I guess maybe it's an okay amount if gravity was bringing it back down quicker. Let's try that. No. Makes sense that if gravity max is 0.1, then we really we maybe only want to be going up like 0.2 or something. This is like double gravity speed. Ooh, that's pretty nice. I like that. Okay, so let's extract this into paddle power. And then put it in here. And we're bouncing. And then if I move to the side, it should fall off. Ooh, and we'll call that losing. So yeah, that's kind of nice. The next thing to make it a fun game is I think we need the ball to get a little bit of side-to-side momentum when you hit it, if you're not quite centered. I think the easiest way to do that is to just measure how far you are from the middle and then apply some small amount of X force to that. So we're going to do that in here. When you've hit, we'll put some spin on you just to get a little example. Maybe we'll just put the paddle power to the side and watch it. Boom. Okay. That's obviously too much and not really under your control. So instead, I think we'll measure how far you are from the middle. So the middle is going to be the paddle X plus paddle half width. So that'd be the middle. And then we want to subtract from that your X position. And then we'll set dx to that. So let's see. So when we hit the middle, it should bounce straight up. Now if we hit the side, whoa, way too powerful. And to me, at least, it looked like it was backwards. So let's try reversing the sign here, but maybe more importantly, let's multiply this by some small number so it's not as dramatic. Function put expected. So I must have wrapped these wrong. Oh yeah, okay. How's that? Okay. So, oh, that's not great. It looks like even hitting the middle, we're sending ourselves off to the side a bit. Let's look at these two values because it could be that we're getting our differences wrong. Maybe we do want this. There we go. Yeah, so the difference has to be negative. Let's see if we're still bouncing the wrong direction. Yeah, okay, and that's very, very mild. That direction kind of makes sense if you imagine the paddle as sort of a U. I don't know. I think it makes slightly more sense, though, to me, that the side of the paddle bounces you the side of the paddle it's on. So let's try multiplying by this negative number instead. Yeah, that looks nice. So we could do a kind of fun thing to make it get more difficult as we go by taking this out into our state and just increasing it slightly each time you bounce. So we'll call this wobble wobbliness of the paddle, how likely you are to get sent off path, and then every time you bounce, wobbliness. I don't like that name. I don't know. Angle. How about just wobble? So multiply it by a wobble, which means we need to destructure it. And then when we hit, we'll add a small amount to it. So this should make it get slightly wobblier over time. So, all right, I'm adding a positive number. I probably need to be adding a negative number so that the angle stays the same. So first bounce, not too bad. Is that getting wobblier? I think it might be. So yeah, fun. Maybe a good next thing, just to show some sort of more gamey type things. I have a bunch of examples here, and one of them includes a sound effect for bumping. I got this, you could find in the README where I got the sound effects from an itch person. So we'll add a bounce sound effect, and then let's play it when the hit happens. So where are we? In here. Play sound, and what did I call it? Bounce sound. And I've been destructuring everything, but you don't have to. We can do that instead. And then let's see if we do this. Yep, it doesn't have it. We have to reset to get it, but let's hear. Nice. I think I have desktop audio being captured, but if not, it is making a nice little bounce sound. Great. Let's also just, I don't know. I feel like we're bordering on making this a rage game if we increase gravity every time you bounce, but we could also do that. No. I think this is probably good enough for now. Yeah. It doesn't take a lot more gravity to get kind of impossible. Also, because gravity is higher, we need to increase our paddle power at the same rate, I think. Otherwise, yeah, the bounces become very low. Give it a little more kick, and then maybe increase the max gravity too, so it could come back down fast. That'd be one way to make it harder. But yeah, hopefully this was helpful to see how you might build a game using this engine. I'm pretty happy with the productivity. I think I spent the whole time thinking about problems in the game and making mistakes related to gameplay. I'll stop this so you don't have to listen to that while I talk. The problem was the thing I was thinking about the whole time. I was barely thinking about the engine or compiling or rebuilding or anything else. So the hope is that means you're able to get to the problems that are specific to your game as quick as possible. I guess maybe if I were to pick some kind of slogan for this engine, it's focus on your problems, not think about anything else. So thanks. Hopefully it wasn't too long. Peace.